Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. We've now seen both OLS and IV in action, so a natural question that arises is, which one should we use? OLS or IV? And students often leave their econometrics course thinking IV is better than OLS. It solves endogeneity. But that's not quite right. The honest answer is, it depends. OLS and IV have different strengths and different weaknesses. Choosing between them requires understanding both very well. So this is one of the most important judgment calls in applied econometrics. Getting it right separates careful empirical work from mechanical application of methods. Suppose that we estimate the same model twice, and let's say we get the OLS, which as like the beta OLS, the formula we've learned is basically covariance xy divided by the variance of x. And then let's assume we also have the IV estimation for it, where we know we've got the covariance of z and x divided by the covariance, z and y divided by the covariance of z and x. Okay. So both produce an estimate of beta 1. They will almost never be identical. And the question is, which one should we report and why? Now, when OLS assumptions hold, meaning I have covariance of x and the error term being equal to 0, meaning x is exogenous, then sure, OLS is unbiased, OLS is efficient, it's ultimately the blue estimator. Okay, and it uses all the variation in x, and we have maximum precision. Now, IV will also be consistent in this case. However, IV is now going to be less efficient because it's not using that exogenous variation or that full exogenous variation in your x variable. It uses only the variation that it's coming from Z, and IV standard errors are going to be larger in this case, okay? So if OLS assumptions hold, there is no reason to use IV. Using IV when OLS is valid costs you precision for no gain. Keep in mind, IV is not just like a free upgrade that you're getting. It comes at a real cost. Larger standard errors, sensitivity to weak instruments, and dependency on instrument validity. So you only accept those costs when OLS is really beyond repair. Now, what happens when endogeneity is present? So we are in the case scenario where the covariance XU is actually not 0. In this case, clearly OLS is biased, is inconsistent, more data doesn't fix it, and OLS estimate is not a causal effect. Now, IV in this particular case remains consistent, assuming the instrument is valid. The IV in this case should become preferable despite its lower precision. Now, a consistent but noisy estimate is better than a precise but wrong one. And this is something that you might want to remember, okay? So a consistent but noisy estimate is better than a precise but wrong one. What is precision for if you've got the wrong one to begin with, ultimately? So that precision is worthless if the estimate is systematically wrong. Consistency, which means like getting the right answer on average as the sample grows, is the more important property when endogeneity is present. So if we were to sort of summarize all of these like trade-offs for when shall we use IV, when shall we use OLS. This table would look something like this. So again, when we've got no endogeneity, OLS is the best. It is unbiased and efficient. IV works, but then why would you want something less precise? When you have endogeneity, you would prefer IV because it's consistent, and you definitely don't want to use OLS because you're going to have both biasness and inconsistency. Precision, again, is going to be higher for OLS because it uses all variation, but lower for the IV because it's only going to use the Z variation when you had no endogeneity. If you had endogeneity, then you would have required valid instruments for your IV estimation, and obviously you would have required to do all of your checks for that. Normally, we would always want X to be exogenous, okay? So for OLS, that is absolutely a must, and IV is what we use when, unfortunately, we can't get over the fact that X is endogenous. Okay, so this might raise the natural question. So now that we know all of these like trade-offs, how do we know whether endogeneity is present? Now, the thing is, we can't directly observe. We always say covariance XU needs to be equal to 0, but we never observe this directly. But we can test whether OLS and IV give meaningful different answers. And that's the Hausman test, which we will cover in the next video. But before we conclude this video, just a little bit of a reminder. Why is IV less precise in general? The IV deliberately discards part of the variation in X, okay? Because it's only keeping the variation explained by the instrument, okay? So less variation used, it's equivalent to larger standard errors, okay? Think of it like estimating a slope with fewer data points. OLS uses the full scatter. IV uses only the subset variation of Z that Z created, okay? So the more the instrument explains X, the stronger the first stage, the less precision is lost. This is why a first strong stage matters for precision as well as for consistency. Keep in mind, a weak instrument barely moves the X, so the IV is left with almost no variation to work with, so obviously standard errors will explode, and that is like a situation you would never want to find yourself in, especially when you know that you have endogeneity present. Okay, I hope this was useful, and I'll see you guys in the next video when we talk about the Hausman test.